Hey guys, this is a video for lesson 7.1.2. It I'm sorry I can't be there in class with you guys today, but hopefully this video explains it well enough. So you should have gotten a handout to begin with, like a warm-up handout like you normally do with 3 problems on it. I'm gonna write those problems out here. We have first simplifying cosine x times tan x and cosine x secant x over cotangent x, cotangent x, and then cosine x over secant x plus tan x. Okay. All right. So simplifying these expressions, cosine x times tan x, again, like you generally want to turn things into sine and cosine. So cosine times tan really is cosine x times sine x over cosine x. This is just sine x, right? Because these cancel. Over here on the right, cosine x secant x over cotangent x. Okay, so secant x is 1 over cosine x, right? So let's write this out. It's going to be cosine x times 1 over cosine x over, let's keep it as cotangent x for a moment here. Well, this is just 1, right? So this is 1 over cotangent x, and we know that's the same as tangent x. Okay? And down here, cosine x over secant x plus tan x. Okay, let's combine these two at the bottom. Secant x is 1 over cosine, so what we have here is cosine x over 1 over cosine x plus sine x over cosine x. That's the same as cosine x over 1 plus sine x over cosine x. And we can do that keep change flip, right? So we then have cosine x times 1 plus sine x over cosine x. Cancel, cancel. Just 1 plus sine x. Okay, so that's the warm-up. That should have been not too bad. And then we're going to get started with the lesson. So go ahead and get out your notes. I do have those. This is lesson 7.1.2. Okay, pause there for a second. 7.1.2. Trig identities, trigonometric identities. Okay, so recall identity is an equation that's true for all variables of the variable. So you could, if you wanted to, you could get on Desmos right now and you could plug this in for Desmos and you'd see that these two are really the same thing. Even though they look very different, they are the same thing. So how do we prove this? So the way that we prove that these two things are the same is to choose a side and change it to be the same as the other. Okay, that's a really basic way to explain it, right? Choose one side and change it to be the same as the other. So again, the general hints that you'll see are changing to sine and cosine, right? You want things to be in terms of sine and cosine often. You could be looking for Pythagorean identities. You could be combining fractions. Okay, these are our main, like the common things that we do to prove. Okay, so let's start this problem. I want this to look the same as this. How do I do that? Well, this kind of is similar to some of those warm-up problems we were doing. one of the hints as well is that you generally want to start with kind of the more complicated side, like sine squared theta. Like there's so much kind of, there's only so much we could do with that. And so getting it to look like this would be quite challenging. It's actually easier for us to simplify the more complicated side. That's not always the case, but it often is. And so again, I think a good thing to think about is writing it in terms of sine and cosine. So I'm going to do that. So secant, that's 1 over cosine. So we really have 1 over cosine uh, minus cosine over 1 over cosine. Okay, that's really what that is. I just need secant to be 1 over cosine. I'm then going to combine that numerator there. So I'm going to, remember this is kind of over 1. So I'm going to multiply top and bottom by cosine x. So I'm going to get 1 minus cosine squared x over cosine x over 1 over cosine x. Again, here I'm going to use these colors. I multiplied this one by cosine x over cosine x. So they became the same denominator. Now I'm here. I'm going to keep change flip. Or you could multiply top and bottom by cosine x. This is pretty straightforward, but I'm going to keep change flip. We'll do 1 minus cosine squared x over cosine x times cosine x over 1. These will cancel, and I'll end up with 1 minus cosine squared x. If you remember from our lesson before, sine squared plus cosine squared equals 1. Therefore, 1 minus cosine squared equals sine squared x. And that's our answer. Now, I don't know why it keeps freezing, but now our left side looks like our right side, and we are good to go. Okay, so that's a proof. We just did a proof. We'll do many proofs, and the best way to get better at them is just to do them, guys. You just got to practice them. All right, here are some more examples of trig identities before I let you practice. Cosine squared over sine equals cosecant v over sine. So if you wanted to try these before I give you the answers, you may want to try them. If not, if you're feeling a little bit scared or kind of uncertain of where to start, then I'll help you. Okay, so first one. These two are the same thing. You know they're the same thing. You're just trying to say that they are the same thing by manipulating one to look like the other. So this is an example of using the left side versus using the right side here. So if we use the left side here, if I look at this, I see that I've got one kind of complete quotient here on the left, but then I've got a difference on the right. I need to change that. So I need to make cosine squared kind of a difference rather than a one quotient. If that makes sense. So again, one of the most common identities we use is sine squared x plus cosine squared x equals 1. So one of the most common ones we use. And by rearranging this, you can find different values, right? So cosine squared really equals 1 minus sine squared. So that's what I'm going to do here. I'm going to rewrite cosine squared as 1 minus sine squared x over sine. I know I'm using x instead of v. It's okay. Okay. Then I'm going to separate that as 1 over sine x rather, minus sine squared x over sine x. 1 over sine is cosecant, and sine squared over sine, well, it's just sine x. So I've done it. Okay, so using that identity was key to getting to this final point. Now I've got left the same as the right, I'm happy. If I did it the other way, if I started with that cosecant minus sine, I wanted to get it to look like the left, you would kind of go in reverse order. You would first rewrite it in terms of sine and cosine. Okay, so okay, sorry again, I don't know why it's lagging. First, you'd rewrite it in terms of sine and cosine. So you'd write it as 1 over sine x minus sine x. And then you would combine these together. Again, the same that we did before, where you'd multiply top and bottom here by sine x. And that would get you 1 minus sine squared x over sine x. Then using our identity, 1 minus sine squared is the same as cosine squared x, so therefore this is cosine squared x over sine x. And that's how you get the right to look at the left. So again, you can do it either way. You can start with the left or the right side, and you can get to the same answer. You know what the answer is, it's just a process. I would recommend that you really take your time and show your steps very, very clearly when you're solving the proofs. Do a couple more examples before you start the homework. Okay, so here 1 plus tan over 1 minus tan equals cosine x plus sine x over cosine x minus sine x. Okay. Again, you can choose whichever one you want. I'm going to choose the left side here. I'm noticing that this is written as tan, this is written as cosine and sine. So, okay, well, I need to write this in terms of sine and cosine. So I think what I'm going to end up doing here is I'm going to end up writing as sine and cosine first. So 1 plus sine x over cosine x over 1 minus sine x over cosine x. And then what I'm going to do is I'm going to combine these. So, we talked about this last class. There's a lot of combining fractions. So really this is cosine x over cosine x, and I'll write that just to make sure that's clear. This is cosine x over cosine x to get it to the same denominator. This is cosine x over cosine x, get it to the same denominator. We're going to multiply those and then add, so we'll end up with cosine x plus sine x over cosine x over cosine x minus sine x over cosine x. Keep, change, flip, right? Keep the numerator. Multiply by the reciprocal of the denominator. These cancel, so we'll have cosine x plus sine x over cosine x minus sine x. And we're happy because that matches the right side. So again, I'm looking at the problem. I'm like, okay, well, this is tan, this is cosine and sine. I have to write this in terms of cosine and sine. I do that. I then combine that numerator, I combine the denominator. Then I'm able to simplify with keep, change, flip, and I end up with cosine x plus sine x over cosine x minus sine x, which is what I wanted. So, all right. Last one. Okay, so look at this one. Okay, 4 tan x, secant x, and a whole bunch of stuff here on the left. It's a technical term. Okay, so when I look at this, okay, well, this left side looks a lot more complicated than the right side. That's the left side. So left side, in order to do it, we're going to have to combine these fractions together. To combine the fractions together, they got to have the same denominators. So what we're going to do is do multiply by 1 plus sine over 1 plus sine, and here 1 minus sine over 1 minus sine x. Okay, so what we'll end up with is 1 plus sine x quantity squared over 1 minus sine squared x minus 1 minus sine x quantity squared. Okay. Well, 1 minus sine squared x, I know that's cosine squared x. So that's going to get me somewhere here. But there's up here, we got this 4. What we're going to have to do here is, even though I want to leave these as quantity squares, I got to FOIL them out. I got to multiply them out. I'm going to get 1 plus 2 sine x plus sine squared x minus 1 plus 2 sine x minus sine squared x over 1 minus sine squared x. Okay, this is looking actually a little better, because what's going to happen is that 1's going to cancel with this negative 1. And the sine squared is going to cancel with negative sine squared, and we're just going to have that 4 I was looking for. That 4 is a little weird. I knew I had to do something to get to that 4. We're going to have 4 sine x over cosine squared x. Okay, this is looking a lot better. We can rewrite that as 4 sine x over cosine x times 1 over cosine x. So that is 4 tan x times secant x, and we're happy. All right. Okay, guys. So for these problems, for the proofs, there is no delta math for that, right? These are not procedurally generated kind of problems. They're kind of unique problems. They're things that you on paper, and what matters is not like the final thing that you circle. It's like, well, what was your process? That's what we care about, and that's really difficult to assess on delta, and that's why we don't do it for this one. So you have your classwork practice and you have your homework. I'll post answer keys for those so you can see, you can check your work. But I want you to start just by practicing and trying them, seeing how you do. Talk to your peers, talk to your friends. Come see me in office hours today after school if you're able to, or later this week. We'll check back in on day 3 this week and make sure you're all caught up. All right, guys. Have a good one.